Good morning, everybody. Storm chase mode is about to be activated big time. Good morning, everybody. This is a live extreme weather briefing as it looks like the chances of a tornado outbreak are starting to increase across a large portion of the central and the southern U.S. You can see the Storm Prediction Center has come out with an enhanced risk that stretches from eastern Arkansas through the Memphis area all the way up to the southern tip of Indiana, and that includes a threat of strong tornadoes. You can see that 10% hatch area there draped across the central and lower Mississippi River Valley. I don't think that all this outbreak is going to happen simultaneously over such a large area, but any snapshot in time, the outbreak will be happening within a subset of that risk area. So I think that the tornadoes should fire initially in the southern portion of that risk area and then spread rapidly off to the northeast, eventually arriving up into the northeastern part of the outlook, possibly by midnight or even the early morning hours on Saturday. Some of the models are showing storms aren't going to fire until well after sunset, maybe even like a 9 or 10 p.m. type of initiation of storms. Still looks like northern Louisiana into southeastern Arkansas, those storms should fire off first and then move off to the northeast rapidly. And so my goal is to chase this, of course. I am going to be heading off to the target area today. I saw there was quite a bit of debate as to whether this is a negatively tilted trough or a positively tilted trough online, but I think it's a little bit more complicated than just placing this system into one of those two different buckets. So I'm going to talk to you a little bit about trough axes as well and identifying those. But this is a unique trough ejection. This is by this afternoon. You can see two different separate entities here, two different troughs. You basically have this cutoff system that is definitely merging with the jet stream here off of Baja California out over the open Pacific. And then you've got the parent trough here diving south across the western U.S. And in order to determine the axis of that trough, you want to see right where it bottoms out. Basically, you'll see these little dips here in the isobars. That is your jet axis. And see how it wiggles back to the west with time? That's the axis of the trough, When it wiggles back to the southwest like that, that's a positively tilted trough. But if your axis is bending back to the right, then it's a negatively tilted trough. This one right here looks like your height contours will be like this, your isobars. And basically, isobars are lines of equal pressure. These are lines of equal height as well, and so your trough axis is more of a neutral tilt with this one. Even though you have more flow on the eastern side of the trough, it's definitely not symmetric in terms of the wind, but this is more of a neutrally tilted trough, and you step forward with time and watch this system eject to the east of the parent trough. Here's your trough axis, right where the curved photographs you see, or the curved lines of equal height. You're coming in northwesterly, and then you curve back to the northeast, right where they make that curve. That's your trough axis, the base of the trough there, and you can basically draw a dashed line all the way down those height contours, and it still bends back to the west. It's a slight positive tilt there, but it does have this lobe of vorticity that gets picked up by the base of this trough and ejects off to the northeast, and the presence of this trough helps to deepen the parent trough as well. It adds shear vorticity at the base of the trough, helps to deepen its overall amplitude. But then this thing starts to lose its identity and ejects northeast as a larger scale jet streak. And that's what really gives this trough an asymmetric appearance. Right here you can see that trough axis, still with that slight positive tilt near the end. And you got to wonder if this system wasn't present off of Baja California, if this trough would have a more neutral tilt. Would it be shallower in amplitude? Certainly, because this jet streak at the base of the trough is helping to enhance the vorticity at the base, helps it to dig, increase in amplitude. But it is starting to lose its curvature and starting to lose its identity, starting to look more as a jet streak that ejects off to the northeast. Right here, it's right near the base of the trough. And overall, I would say that this is quite a neutrally tilted trough here. If you include our separate entity at the base as kind of the base of the trough, you can see a little bit of some ripples that go back to the southwest. But there are still two different entities. You have this parent trough here, And then you have this kicker system rounding the base of the trough. We've been talking about this for days leading up to this event. But that rounds the base of the trough, ejects northeast as more of a jet streak. But it does pick up some dry air in the mid-levels of the atmosphere over the Mexican plateau here. And that helps to boost the instability, steepen those lapse rates in the mid-levels of the troposphere. And I think that's setting the stage for an outbreak of tornadoes here. This is tonight. So you can see it's now starting to appear as more of a jet streak at the base of the trough. Still enhancing that shear vorticity at the base. Definitely deepening that large-scale trough. But it's still basically two entities. You have this little trough here marching along the base of the trough, helping to deepen it. And then you still have our old trough axis. Looks like more of a neutral tilt here. But it definitely is changing its structure, given that little vortmax at the base of the trough. And then look at it overspread as a jet streak. Probably have a trough axis right here with that subtle cutoff system that's ejected over northern Mexico across the east side of the trough. Your parent trough still here back behind it. That's your main trough axis, but definitely more of a neutral tilt. Went from a positive tilt to a neutral tilt, and then you've got this lobe of vorticity ejecting northeast that appears more as a jet streak. And this jet streak here is key to creating an asymmetric, what appears to be a largely positively tilted shearing out trough, but it's really not the case when you look deeper and look at the full evolution of this trough with this vortmax ejecting off the east side of the trough more as a jet streak. This is at 18Z on Friday. And then your outbreak's about to begin by 0Z, but look at these jet dynamics. And it still has quite a bit of flow on the backside. This is your trough axis here, so it is gaining more of a neutral tilt by this time, by Friday evening. And you probably could draw a little trough axis down here as well, but it's lost its identity by this time and is ejecting on the east side of the trough as more of a large-scale jet streak. Really, it's this little sub-jet streak down here in Arkansas that might be able to fire those storms at about 7 or 8 p.m. in eastern Arkansas. Probably the right entrance region of that jet as it lifts off to the northeast will help to fire those storms in eastern Arkansas, and those will move rapidly northeast through western Tennessee, western Kentucky, eventually up into southern Indiana as we go through the overnight hours. But what an incredible trough ejection, and it's more complex than just a shearing out positively tilted trough. It appears asymmetric here, but a lot of this flow is because of that cutoff system that was located off of Baja, Mexico, that ejected off to the northeast. So let's take a bit of a deeper look now at the 850 winds. This is that low-level jet I was telling you about, and that is a monster low-level jet. Basically touches 25 states, even a Canada province up there in southern Ontario. But this is about 1 kilometer above the ground. Anytime you get 50 to 60 knots above the ground like this, with moisture underneath and surface-based instability, with relatively veered upper-level winds, relative to that, you're likely going to get tornadoes. And what's going to initiate these are those prefrontal confluence bands that always exist ahead of a trough or ahead of a front like this. You're going to have prefrontal confluence bands throughout this warm sector on the mesoscale that we can't yet identify, but as we get a little bit closer, I think that those high resolution models are going to be more effective at picking out those areas. So here's your 0 to 3 kilometer EHI, and notice how we have much brighter colors here. That's at 9 p.m. Central Standard Time. This is at 0Z. This is at 6 p.m. Central Standard Time, but bright colors down here. The models are trending toward greater instability, as they often do as you get closer to an event like this. Let's zoom in a little bit closer to the target area. Moisture is definitely not going to be an issue, of course. Dew points well into the 60s. And this is also coincident with that right entrance of that little mesoscale jet. And I do believe that storms will likely initiate here, south central Arkansas, maybe into north central Louisiana, maybe back toward the Shreveport area, and rocket northeast at 50 miles an hour. What we're getting here is a big, strongly sheared warm sector that's developing out ahead of this. You can see all the oranges and reds, basically a highway of low-level wind shear and surface-based instability that these storms are going to move along. And it's only going to increase with time as you go to 9 p.m. just after sunset. These colors start to get even more bright. Western Kentucky, Western Tennessee, Southern Illinois as well. I wouldn't be surprised if you get a 2% area or a greater tornado probabilities extending into Central Illinois with this system as well. Looking at the surface dew points with the NAM, now you've got 60 plus punching all the way up into Central Illinois by 9 p.m. and even 50s up a little bit further north. So those tornado probabilities are going to need to be expanded off to the north as well, and to the northeast here in east central Illinois. That warm front lifting up, and this is by midnight here. Warm front knocking on the back door of Indianapolis, and you're going to have a racetrack of tornado-producing storms ahead of that front. So that front's back here in the Ozarks. These are going to be prefrontal confluence lines that will initiate these storms. You could even see little bands in the moisture hinting at some of those prefrontal confluence lines, even in this NAM model, the operational NAM, low resolution NAM. You go to the high resolution NAM and you can still see these little bands within the dew points. Those are going to manifest as prefrontal confluence lines that will initiate these bands of storms that will rocket off to the northeast through the central Mississippi River Valley and the Ohio River Valley there. Interestingly, the 3-kilometer NAM doesn't have very much in the way of storms, but you can see these bubblers down here, northwestern Mississippi into eastern Arkansas. That's likely where these storms are going to initiate, and these are going to be renegade storms in eastern Arkansas, up through the Memphis area, up through western Tennessee. Looks like another band of storms here developing a little bit closer to that surface low into central Illinois. Some bubblers as well down here along that advancing warm front up into southern Indiana. Basically a band of storms, fast-moving supercell storms throughout the central Mississippi River Valley. That's the 12ZHRRR. ZHRRR initiate storms very late, about 10 or 11 p.m. I think they're going to be a bit earlier, but look at this arc of supercells up there. Central Illinois, those are going to be nasty, and you're also going to have a mode down here into central Arkansas, as well as some prefrontal confluence lines of convection into northwestern Mississippi as well. So I think you're going to have a couple different modes. One up here, eastern Illinois, that's eventually going to march into central Indiana as well. This is about 10 p.m. Central Standard Time, so this is going to be a late evening, overnight event, but I could certainly see these being tornado producers into central and southern Illinois as well. Pretty nice photographs there. Let me get rid of my head so that you can see that photograph. There's your wind shear. Due southerly wind at about 15 knots at the surface. 1 kilometer wind, pushing 60 knots up there in Illinois. So very strong wind shear. And even though you have a critical angle at about 30 degrees, you're still able to squeeze out close to 400 0 to 1 kilometer storm relative helicity with this shear profile. But I tend to not focus too much on the individual convection. What I do see, though, with this event are renegade storms that are relatively isolated. But notice how this wind shear ejects rapidly off to the north, up across central and southern Illinois. Very strong wind shear out ahead of this convective line, extending all the way down to the Missouri boot heel. A little bit less shear as you go closer to the midnight hour, late evening. There is that front surging through central Missouri. This is 2Z. So about 8 p.m. Central Standard Time, big wind shear here in the St. Louis area down south. Not sure if there's going to be any surface-based instability there. And there is. Look at that 0 to 3 kilometer cape nosing up into the St. Louis area by 2Z. An abundance of instability. Storms will try to fire here. It looks like just south of St. Louis. Probably will fire in that band there of 0 to 3 kilometer cape. And you get some more 0 to 3 kilometer cape southeastern Arkansas, northern Louisiana, up the Delta as well. Pretty favorable photographs there in St. Louis, additionally. So I do think that St. Louis is in play for tornado potential Friday evening as well, based on the HRRR model. Storms will be initiating very close to St. Louis. Then as you go through the evening, that convective line marches into central and southern Indiana. And some new storms develop down near the Arklatex about 10 or 11 p.m. And you also have this stripe of enhanced 0 to 3 kilometer cape. You could basically see these prefrontal confluence lines, and I wouldn't be surprised if renegade storms late night also initiate out in this environment. Plenty of surface-based instability with those upper 60s dew points as well. That's the main front as it's moving off to the east. The significance of this outbreak depends on how well these prefrontal confluence lines convect. If they don't convect at all, then it doesn't matter how favorable the environment is for tornadoes. They're just simply not going to happen. Hopefully that's exactly what happens out there. It looks like the 12Z HRRR is showing these renegade bubblers to be a little bit less robust, but I think they're going to be there. Let's see what the trend is up to 15Z. Oh, we got it. It doesn't go out far enough. We'll just have to wait. Friday evening. Let's see what happens when you go to 9Z here. You got storms everywhere by 8Z, 8 or 9Z here, about 2, 3 in the morning. Finally, that prefrontal band of convection really starts to rip. You also have a band of some supercells in central Indiana, the original central Illinois mode, starting to move into western Ohio. These will even have some tornado potential, as will these renegades out ahead of it, moving pretty close to the Nashville area by 9Z. Looks to me like it's going to be an early morning type of a tornado potential. And one thing that's scary that the HRRR is showing here is that this is definitely a broken squall line of storms. So those are individual discrete storms within that will likely have tornado potential. Main front is actually back here by this time, cutting through Arkansas back into northeastern Texas. These are prefrontal confluence lines, textbook for tornado outbreaks. And then you look at the 850 winds, the low-level jet that's embedded within, and look at that, 60 to 70 knots into central Tennessee, northwestern Alabama, back into central Mississippi as well. Big flow up here, massive low-level jet continuing to dominate by this time. Surface-based instability all the way up into central Indiana, and it looks like the environment is actually most conducive for tornadoes across northern Kentucky into southern Indiana and even southwestern Ohio there by this time, by 9Z. And then also pretty favorable environment for tornadoes all the way down. Really anywhere where you see these colors there, there's going to be potential tornadoes. The 0 to 1 kilometer shear actually increases along the front, out ahead of the front, ahead of this prefrontal confluence line by about 2 to 3 in the morning. And pretty favorable conditions here for an outbreak. It looks like just Friday night into Saturday morning. There is a marginal risk down here over the southeastern U.S. that includes upstate South Carolina, back into northern Georgia, into central Alabama. I wouldn't be surprised to see some tornado warnings and an upgrade to a slight risk during the day on Saturday as this convective line continues to push off to the east. But definitely looks like a slightly later initiation of storms, but you got to get out there right at sunset anyway, just to make sure that those storms don't develop earlier. A lot of times during these winter setups, the real dynamic, kinematically sound winter setups, usually convection will initiate a little bit earlier than you might anticipate. But this is at 23Z on Saturday, just as this wind shear is starting to really ramp up across southeastern Missouri. The delta is relatively wide open. I don't think there's going to be storms before sunset down there. The wind shear really doesn't arrive until like 10 or 11 p.m., so it's going to be a late show. I could see up to 12 to 24 tornadoes total or so over the entire warm sector. I don't see this to be those 100 tornadoes or more type of an outbreak, obviously, but I do see this as an outbreak, middle to lower end type of an outbreak, spread out over multiple states as well. Probably get a lot of tornadoes up here in Illinois, central southern Illinois. That's big wind shear up there ahead of that surface low, closer to the surface low. A little closer to the surface low, you really get some big wind shear. So I'm going to have to decide between covering up here, up into central and southern Illinois and following in Indiana and then dropping down, or do I play the southern mode, northwestern Mississippi, and just ride it on Interstate 40 or Interstate 20 off to the east? I'm leaning toward Interstate 40 or maybe further north up into southern Illinois, southern Indiana. Western Kentucky could certainly be a good bet to intercept this event. But we still have a lot more models as well. Many more models to analyze. But you know that's going to happen. The dew points always end up surging further north than many of the models are showing. I think we could get tornadoes from Indiana, southwestern Ohio, central southern Illinois, all the way back down through eastern Arkansas, down to the south here. Anytime you get a massive area of mid-60s dew points like this, with favorable surface-based instability, large bulk shear across the entire warm sector, you're going to get pockets within this where the conditions come together perfectly for tornadoes. It's inevitable that there's going to be prefrontal confluence lines as well ahead of these events. And it just looks like an outbreak to me, everybody. SBC's on board as well with this enhanced risk. I think that there's going to be limiting factors with the convective allowing models showing how expansive the convection is going to be and how many tornadic supercells evolve across the warm sector. I think that that's going to happen right up to the event. So I think that that could preclude the issuance of a moderate risk for this event. Probably an enhanced risk, a large enhanced risk like this with that strong tornado potential. I do think that that should be enough for this one, but I wouldn't be surprised if there is an upgrade to a moderate risk, as that system that's moving across northern Mexico is going to pick up that dry air in the mid-levels of the atmosphere and help to overspread that elevated mix layer over top that large reservoir of those 60s dew points. And that's why I do think that this is going to be a pretty substantial event. I'm going to leave this afternoon, point the ship west. I do have a couple transmission issues with the Dominator 4, but I am going to be bringing the Gravitron network out there, hopefully to deploy 8 Gravitrons out ahead of the tornado today, 8 of them. I'm going to be flex taping those Gravitrons to trees, structures, the side of the Dominator 4, and the goal is to paint a picture of the very high resolution pressure fields around a tornado so that we can capture the propagation of those gravity waves through the network of Gravitrons. So now is the time to get those severe weather safety plans in place. If you live in this risk area, you definitely want to stay tuned to those warnings. I know I'm going to be up all night chasing this system. And I hope you guys do enjoy my weather reports as I'm streaming live. It's definitely going to be one of those streams, though, where I'm just driving around in the dark for the whole entire night until Saturday morning, until the sun comes up. But it is possible that I could be on a tornado once the sun rises as well. So I'm going to stream live on my way out to the target area so we can discuss this further, discuss life as we're heading out there. I'm going to have Gizmo stay back here at my mom's place so that she is comfortable. She gets a little bit of anxiety now driving around in Dominator 4, I think because of the roof rack vibrating on the roof. Almost sounds like hailstones to Gizmo, so I think that she's getting a little bit upset over the noises that are made inside Dominator 4. So thank you, everybody, for tuning into this weather report. Thank you, Facebook supporters, for making live storm chasing and live briefings like this possible. If it weren't for you guys, I wouldn't be doing this full time. I promise you that. I'd probably be working as a weatherman somewhere, or maybe pushing carts at Kmart, or probably slinging weather briefings here. Definitely would be living at my mom's place, but I'm living here regardless during the cold season, especially to intercept the Mid-South leaf peeping season through the winter storm season into the spring Mid-South season as well. So thank you, everybody, for tuning in. Thank you, Facebook supporters, especially for riding around in my passenger seat during these storm chases. And I welcome you to ride along again in my passenger seat Friday night through Saturday morning. Never stop chasing.